Hello, let's get started. And today is again Sunday. It's Python Zero to Hero. Today is going to be just a short episode to have a brief introduction of the Python, functional programming in Python. There will be much more that I don't feel like covering today because I just want it to be a very brief introduction, and then maybe next week we can talk a little bit more. I will explain later when I go into it. First of all, our achievement wall. This is like filling up so quickly. And I think that's great. I'm starting to like run out of idea. I know that a lot of topic I can go a little bit deeper. That I may revisit some of those, but yeah. Let me adjust my camera because like it's very weird. I feel like my green screen is starting to get not big enough for some reason. But okay, yeah. I feel like that. I may have to revisit some of the topics that I've talked before because I just feel that maybe it's too rushed last time and I didn't go deep enough, or maybe I learned something more about it that I want to talk about. I always think that there's some little things that I forgot. For example, like lambda function. Last time I didn't talk about it in when I introduced functions, and we gotta use it today, so I gotta revisit it. So yeah, I always think that maybe sometimes it's good to revisit certain topics to add something more to it. If you have listened to me like since the day one, then yeah, just like yeah, because I'm starting to like feel that I'm running out of ideas, and also like I am not a very organized person, so my syllabus is gonna be a mess. That's why I can't become like a teacher in school because I have no syllabus. I just like think about what I want to talk about and talk about it. so Today I gotta just talk a little bit about the functional programming in Python. Python is not designed just for functional programming, but yesterday like I meet up with a bunch of friends, and then they talk about kind of other programming language like Scala, and they're like actually like mainly functional programming. Well, Python have that as well. Python also have that, but of course you can use Python not in the functional programming way. You can still do like object-oriented programming. But because of the like very dynamic nature of Python, it also provide those things that you could actually do functional programming with Python. Um, so today I just gonna cover the surface of it, like everything else. But yeah, I will see like what I could, you know, what I could cover, and yeah, we'll see. Like maybe if I feel like it, I may talk a little bit more than I prepared. I don't know. I think I need some inspiration, and I really like it if people ask questions, and if you just send me a message telling me like you have watched my videos and like what you want to know about more, that we could have it. I don't know. I feel like that it's very difficult to like do live coding um stuff like streaming, because like I know for gaming that there's always a new game coming out, and there'll be people playing them. But for programming, I think like you can always start a new project, but yeah, I just feel that it's a little bit difficult right now, that I need some inspiration. Right, any idea is a good idea, so just let me know. I found on Wikipedia, like I always do, I found it, just like what's the definition of it. I'm still like not so sure. I just know that, for me, it's just like feel like that you do things slightly different. Uh, there's a very good example in Wikipedia that actually, so yeah, it's just said that it's, construct the program by applying composing function. So rather than like using for loop and changing the object itself, you just apply a bunch of function on it to change it. One example that is they have on Wikipedia is that it was in JavaScript. I changed it into Python. So you see that now I just want to like make this num list into something different, okay? And then I would, so basically what I did here is that I would found those that actually can be divided by 2, so the even numbers, and then I would multiply them by 10 and add them up. So that would be the result of it. So actually it involves quite a field of operations, and then I could rewrite this into functional programming. So actually, to prove my point, I gotta run this to like so that you can compare. So I gotta actually add these two cells here. So these are the ones that before. So I gotta put this here, right? So yeah, like I said, this is just like having a list of numbers, and what we gotta do is that we gotta pick out the even numbers, multiply them by 10, and then add them up, right? So if you execute it, nope, it's not showing, so I need to show result. And also it's complaining something, maybe the indentation again, because copy and paste kind of ruined it a little bit for me. So yeah, you can see that the result is 300 for this one, because you pick out the even numbers. So 2, 4, 6, 8, and 10. So it would be 20 and 30, right? Okay, so 30, and then multiplied by 10, so it would be like 300. Yeah, so this is what you get. So this is one way of doing it. This is like, I think most people would do it this way, right? Write a for loop and then just like calculate it and accumulate them. Um, but there's another way. Sometimes I feel like it's a Pythonic way of doing it, because actually it doesn't. Because for me, it's like in the past, I usually, if I do write a program, when I was in school, well, I didn't study computer science, but I did, did some computer courses, and so when I did it, I was just like, write a for loop and do it, right? But of course, I didn't study computer science, and then I kind of like put programming aside for a decade. That's how old I am. And then I go back into data science, and I start coding in Python again. And I feel like there's new way of doing things, so I would just call it a Python way of doing it. But actually, this is there's a philosophy behind it, and this is called functional programming. So uh, yeah, Python is kind of like both, right? So it's like you can do things this way, but you can also do things that way. So yeah, so well, you can see that we kind of using some new stuff here. Reduce map. I will explain those like afterwards. You can see that I've prepared the coding space here. And also there's like Lambda function that I didn't explain last time when I talked about functions. And so yeah, to make it up, so I got to talk about it today. Actually, it's not something very heavy, so we could cover that very easily. Um, so yeah, so all these code, right? I won't explain now, because like I gotta explain later. But like you can see, this is basically doing the same thing. So I forgot to print out the result again, and let me put it here. So yeah, it is doing the same thing, giving the same result. But what it does, you can see that like I kind of apply a bunch of functions on this list. So rather than like I changing each one of these, and then I kind of having a result to hold it, I just apply a bunch of functions on it. So the result is just a bunch of function calls. So this is the characteristic of functional programming. And let's go back to the slides. Um, so why do people do that? So what are the advantage and disadvantage? So you can see that the advantage is that well, this is not a very good example, because it's like a chain of them, right? But just look at like if you just look at this part, so it's actually easier to understand, because like this is, well, the filter. First of all, this is very straightforward. It must be something to do with filter, and this is the filter criteria. So this is the filter that we apply, and this is the thing that we apply it on. So it's quite simple to understand in some way, because it's just a bunch of function calls. um, and so yeah, like the argument and the return type are just like provided. So everything is so transparent. Everything is just this function call that you can see like all the operations just in one go. This is actually just one line. I break it so you can see it easily, but you can just put everything in one line. Well, it's not very readable if you have things that's chaining up like that and you put it in one line. But if it's just one thing, for example, like again, you just look at this last bit here, actually it's very transparent that you can see, rather than a for loop. Then you have to think about what do you do in the for loop, right? So for example, if I just like do this num, and then I append it to the results, and you have to think about, oh, actually I only picking the even one. So but this one is very straightforward. I filtered them out, and that's it. um, so also avoid changing variables and any data. um, so one thing that may happen, I would use the this example again. So one thing that it may happen is that you may actually like you may actually want to like you know well it's not recommended, but if you change the list of it like so because list is a mutable object, so actually there's a chance that you can change it. So if you do a for loop and things like that, you may accidentally change something inside, and then and then it's just kind of mess up your whole program. And also the other thing is like you have to create this result and store them, so it's kind of like you have to create an extra stuff. Rather than compared to this, actually I don't have to put result here because the nature of Jupyter Notebook, if I do it this way, let's indentate it correctly. Okay, yeah, I can still get 300, right? Because like I don't actually need results. So it's just a function call and I get the result. So yeah, so this is avoid like creating variable and like you may change it and then it may kind of ruin the other part of your program. And also you can actually do a lazy evaluation. So I can't say for sure for Python because I'm not so sure like when it got evaluated, but like for things like this, right? For things like this, obviously it will only got executed when Python hit this line, right? And it will just like execute this bunch of function calls and then you will give 300. Compared to like this one, that with the for loop here, actually it needs to execute everything, like looping through it before you get the result. So actually, if you, for example, if you don't use result, like you only use it like, for example, if the user want to find a result, if they print it out or something, then actually you don't need it, right? So for example, let's put it this way. So I'll wrap it up again a little bit more. Um, so here, so you can see that I execute everything until I hit print result. So before I hit print result, actually result is already calculated, right? So, but what if this print result actually is done by user? If a user kind of input something and trigger this print result, then only at that time this result is needed, and only at that time then I should only like calculate all these things when the user asks for it. But in this case, the case above, that's not functional programming, then actually you would already like calculate all the results until you hit this line. So in this way, then you can't lazy, evaluate it. Uh, yeah, like with Python, I think this was is not that much big of a problem, and like kind of for some application, it's not that big of a deal. But like I think for some application, maybe you want something like this, right? Only when for example something's triggered, then you have like hit this print function and then you just execute everything inside. Okay, so this is lazy kind of execution. So if no one's asking for this print, then well nothing's gonna happen, right? So um, yeah, so this is like sometimes lazy evaluation is this desirable, and then if you write code this style, then actually it's easier to do it. No hidden outputs because I didn't, so this is like you could have some hidden output here. For example, you store num somewhere, there you have some hidden output, but this one is like very flat, like you see what you get. So yeah, nothing's hidden. Um, and then oh, also this like kind of for this no hidden output thing. So this also like have speed of a comparison to object-oriented programming because uh, like object-oriented programming, I don't know whether I can find an example here. Maybe the TDD thing before that we had, like for example, yeah, things like that. So it's a little bit object-oriented, right? So I have database, I have basket. So things could be quite hidden there because like you have to really trace like, okay, what have I done to this object and what method I've called from this object. You have to chase them back. But for functional programming like this, if you compare to this one, so like everything is just like one pass to the other, like first straightforward. You don't have to think about what's in that object. So it's kind of saying in a sense, all these actually saying in a sense of a comparison with a object-oriented programming as well. Um, Also enhance the comprehension and readability. Like I said, this one you have to trace like what happened to that object. Like for example, when you debug it, you have to maybe trace like what's the inside, like the attributes, the state of that object. Um, But for this one, like everything is just like one passing to the other, so it's like quite easy to kind of in your mind to dry run the code, right? So you don't have to like, so there's no intermediate state that is stored somewhere, so you kind of like you can, it's rather straightforward compared to the other one. Of course, something this nested is a bit difficult to read as well. So here comes the disadvantage. Okay, so so reduction in performance, because there are a lot of recursion here. So it's kind of like the other side of like not storing any intermediate result. So sometimes this one, like, you there will be recursion, and then you kind, yeah, like I said, you can store the intermediate result. So sometimes the performance could be worse. Also sometimes hard to read, like in some cases. For example, this one, I think you won't prefer to read this. One, because you're not familiar with functional programming. Second is that, well, what's going on here? Like if you squeeze all of this in one line, you don't want to read it. Um, so in some cases, it's actually bad for readability as well. Um, also it could be tough to combine these functions. This is a very simple use case, but sometimes like you would rather prefer to do things differently. For example, if you're writing a big program, like doing things like that could be quite tough, especially when you're not familiar with it. And yeah, so like recursive style. Yeah, so again, like creating something like this is actually not as straightforward as creating a for loop. When I started Python, for pandas, actually a lot of times you do things in a functional programming way. You apply different functions to your data frames to change stuff, rather than like going through your data like bit by bit. So that's a very good example actually using pandas. So rather than going through your data bit by bit, um, using a for loop, you just apply some function to it. So that's functional programming. But it's so difficult to get my head around and write it in a pandas way, instead of doing a for loop. So yeah, so that's why like sometimes it's quite scary, especially for people who are not familiar with it, to do it that way. But there are advantage, of course, like doing that, like I said before, disadvantage, and also especially in pandas, then because it's designed to actually make it efficient, because it's using NumPy and all the like algorithm behind it, and it's actually designed to be more efficient if you do it in a functional programming way. But there are lots of reason why, like, well, like I said, it's not optimized also because like it's optimized to do like multi-processing and all this stuff as well. So, well, you can't do it in a for loop, right? Because for loop is one by one by one, so you can't actually take advantage of that. So, so yeah, you can read a little bit more if you want to. I just like get this point from the blog, and also they have a definition about like what is functional programming. So it explains a little bit more than what I did. But basically that's very interesting because like for people like me who have done Python for a while, actually you would have already done some functional programming, kind of more or less, like, somehow, but you're not you don't realize it, right? So it's just anything that you don't do a for loop to it, you kind of apply a function to, especially in data science. Like if you apply a function to a data frame, then actually you are doing this functional programming thing. So to do what I did before with that for loop thingy, you have to use a Lambda function, map, filter, and reduce. So what are they? So like that's what I've got to talk about today. So yeah, let's go to Lambda function because, like I said, sorry that I didn't cover it last time when I introduced function. So Lambda function is actually a enormous functions because like when you create a function, for example, you have to have a name, right? So my func or whatever, you have to have a name of it. Um, So, for example, if I have my func, and then, for example, what I did is that I would have ticket number n, and I would return n square, let's say. So this is just a normal function where I can do it. I can use it like this, and have 10. That will give me 100. But sometimes there are times that you don't want to write a function in this way. So to write a function that is equivalent in lambda function, you can do lambda and then you can take the n is actually the parameter here, so it's like the input parameters, and then you put out the return here. So yeah, now you see that you create a lambda function, okay? So actually what you can do is that you can do the same thing, right? So you can actually assign it to my func, or my other func, my lambda func, let's call it. My lambda func is this lambda function, so I just put this lambda function object into here, and then I could actually do the same thing, right? I can actually do the same thing that, well, basically it's the same. It's just a different way of writing a function. So this is exactly equal to this, okay? So, but why we want to do that? Why, like, well, if you assign it again to something else, then of course, like you given a name to it, it's basically like the same. So you don't see the benefit of doing that. But when you do things like I did before, like this, you can just use it somewhere without like assigning it to a variable. Um, so it's kind of handy. It's kind of you can do it like, for example, for item in. Uh, so you can actually put this in a list. So yeah, so actually, like, yeah, it's difficult to put this, but like, for example, if you are using pandas, I don't I have pandas here, but like, okay, let's see. So for example, I have a data frame, and you can use dot apply, right? So for example, you have you want to apply a function to it, so you can of course apply my func to it, right? So um, okay, so like you apply this function to the data frame, okay, but sometimes you don't want to write it separately, so you can actually put something like this here. It also works. Okay, so yeah, so yeah, like it's just another way of writing a function. It's not fancy, but you won't see the benefit of it until you kind of use the other things that I gotta introduce today. So let's talk about mapping now, because it's difficult to showcase lambda function without those. Um, yeah, like most of the cases that I use lambda functions, like I said, I use pandas, I use dot applied, and and I just want to apply something, very customized to whatever. I can write a function like this if it's more complicated, but if it's just a very simple operation, I can just write a lambda function. um so yeah, but like most of the time I use lambda function when I use map. So what is map? Okay, so maybe let's look at the documentation as I can explain a little bit more. So map actually take a function as its first argument, and it takes iterable as a second argument. Okay, so an iterable is like anything you put in the for loop. So it's like for item in something, so that something it needs to be an iterable. I think I explained it a month ago, maybe, like in the iterator episode, that you can check that out. But now you can just think of it, if you don't know about it, you can just think of it as like a list, or a dictionary, a tuple, and things like that. Those things that you use in the you loop over in a for loop. So you have something like that, and you apply. So you have a function and that. So what it does is that actually you applied a function to all the iterables in all the other stuff in this iterable, all the things that it will yield in this iterable, and then it will just create another iter another iterator. Um, so basically, is well, this is quite kind of technical way of saying it, but like the easiest way to think of it is that you would have a function. Let's say I put a lambda function, my lambda function here, okay, and then I could have 1, 2, and 3. So I have a list. So a list is iterable, and then I just apply a function to it. Like I said, again, you can put my func here. It's just fine. But we're doing things like that because like you don't want to especially write a function like this just for taking the square of it, then you can just write a lambda function. Okay, so yeah, it will give you a iterable object. So this object is iterable actually. So I can assign it to mapper. So you can check out that mapper actually is iterator. So let's have a look. Oh, I haven't assigned it yet. So yeah, this mapper thing is actually an iterator because it got the iter here, right? This is an iterator. You can change it back to a list if you want. So you see that if you change it back to a list, it will give you one, square, and then two square and three square. So this is useful. I usually do things, I would usually write a lambda function in it because I don't want to write a function just for taking the square of it. So this will be the case when, like, for example, I know that I have a list and I just want to make them all squared, and I would just like call this and then put a list wrapping around it, maybe I would keep this here and then I would just put it separate. So what I do is like, oh, for example, I have a list that is 1, 2, 3. So what I want to do is that I want to, give a list of the square of 1, 2, 3. I would just do this, okay? This is usually what I would do. Of course, like, well, sometimes not, like it's more than just a square. For example, I have a dictionary and then, these are the values and I want to take the square of these values, then, it's slightly more complicated than just like put the, maybe the key of the dictionary here and then you just like, or use the lambda function and call it. And yeah, I just can't think of like immediately an example there, but you will see, like, if you look at some of my code, you will see this kind of like sometimes it will pop up because this is handy. You can just put it in one line and you don't have to, the benefit again, like you don't have to assign things, like, you don't have to have, okay, my list and then create a function and then put for and then write for loop and put each one of them in it and then, uh, construct another list. You don't have to do that. You just like, function call after function call. You just like, just put a lot of jacket on it. So like, and then it would just become something that you want. So this is what I like about Python. Uh, so as aside, another joke, not the joke, but like someone that did something crazy is like try to write everything in one line. So just like write a script of code, a Python code in just one line. So um, it's doable because all this stuff that is Python provided, but of course this is horrible Python code because you're kind of squeezing a program into just one line, which is like totally not readable. Um, but you can do that. So okay, so now you ask about like what if I have a list? Okay, so I have a list. I have like some numbers, and I have some negative numbers, I don't know what they are. So I have this, and then I just want to pick out the non-negative integers because negatives are not allowed. So what you gotta do? Um, so there's something very similar to map. Because map is always, applying something to each one of them. You can make these two 0, but what if like I just want to delete them like once and for all? Then you have to use filter. Um, Again, like you can do what filter is doing in a for loop, but there are benefits of doing it. Like, well, that's the whole point of it, and I've explained it, before this streaming. So, um, so it's the same thing with map. So what I gotta do is that let's call this my list. Okay, so I don't have to type the whole thing again and again. I'll copy and paste. So for example, I want to pick out the positive one. So I will have lambda. So whatever x. Well, usually people hate, a variable name with just one character. For lambda function, I would be more flexible if you ask me, because it's quite obvious what the lambda function is doing. So I don't think that's horrible code. Um, yeah, I'm just like more relaxed with lambda functions. So um, so now it's like so for lambda function, for filter, actually it will only filter the elements that are true. So the check need to make uh, the one that I want to keep to be true. So I want to keep the positive one. So to make it positive, so all the positive will are greater than 0, right? So if you check whether the positive integer are greater than 0, they will all be true, and the negative one will be false, so the false will be out. So if you want to include 0, you have to put the equal here, okay? So that's our function, and then I put in my list, okay? And this will give me, oops, it's not defined because I forgot to run it. So yeah, again, like it will give me an object, okay? So this is very similar to the map object that we had before. So if you look at it, so let's assign it to, um, if you assign it somewhere and then look at it, then, oops, yeah, again, it's an iterator, right? So it's got an iter here, so it's an iterator. And if you want it to be a list, you can just like put it back to this, and it will become a list. So yeah, so the main difference between map and filtered is like filter, you just want to pick some elements out of it. You can use it in combine with map. So for example, I want to pick them out, and then I want to minus 10 out of them. Then you could basically, chain them. For example, I have this. Okay. So this will give me all this, you know, all these positive integers, right? Now I want to, take 10 out of them. So what I gotta do is to write another lambda function. And then this time I would be like x minus 10, okay? Then I will get a mapper thingy. I want to turn it back to a list. I put it in a list. Yep, so now it's like kicking 10 out of them, right? So you can use them in combination, or you can just use one of them. Yeah, filter is also useful sometimes, like you want to filter something from the list. For example, you have a lot of, it's like, yeah, for data handling it's very useful, because like if you have some NAs, some nuns in it, you want to, filter them out, then yeah, then it's useful. So so those two are actually quite common. They are built-in functions, map and filter. You can just use it without importing anything. So the last thing that I plan to do that is reduce. So yeah, so actually I can have more to introduce to you. I have a reference there, but like yeah, I think we will have time to maybe go through something like sorting or something like that. So yeah, the sorting I was planning to reserve it for next week. So we'll see after this. So um so for reduce, actually, like if you have done some like functional programming, actually if you have do things like yeah, like Scala, then you'll be familiar with it, because you always like everything's map and reduce. For example, you have like those kind of like multi-processing kind of thing. Then you will have like workers and then map and then reduce. Okay, so this is not alien to some of the people, some of you who have done those kind of multi-node kind of programming thing before. So I have the link here to this functional documentation. So I think last time we looked at functional was that I talked about decorator. That is the wrapper decorator that helps you to write a decorator. So here we can actually find the reduce here as well. So it's kind of like some extra tools for you to create function stuff. Um, so again, you have a function and then you have an iterable there, but the function that you write this time is actually describing how you combined the things in your list. So the most common one is the one that I've done before, is to add them together. So for example, I have my list again. So my list, and then what I can do is first of all, I have to import it first from func Oh, did I spell it correctly? Yeah, functools import. I think I spelled this wrong. Yep, reduce. Then I can use reduce. So reduced. So the function I put in would be, for example, like if I want to sum them up, it would be x and a y. That would just return the sum of it. So yes, then I'll add my list up for this video. So you can see that is minus 407, which I to cross check my answer, I'll just do a for loop, or I can just call sum. Actually, for sum, there is a built-in function to do that. So yeah, this is a bit redundant, but if you want to do things more than just sum of it, then you could write something else. For example, let's do another example here. For example, I want to what do I want to do with, maybe I want to like okay, maybe I want to make them into a string and then I would chain them together. Okay, so this time instead of just adding them up, I would like to put them like together in a chain. So let's see. Yeah, so now I would just like, it's a bunch of numbers with some dashes there, which is the minus. Um, or I can, make it an absolute value. So I can filter it out, so, like I did before. So I can filter it out like the filtered here. So I would use this, so the minus would go away because I've filtered only. Oops, there's no initial value. Who? Okay, because it's a iterator, I guess. That's why it's kind of not happy with it. Oh, what happened? Did I not run this again? Uh, right. Yeah. Why it doesn't like it? Ooh. Okay, so let's check the documentation. This is very interesting because I've never encountered this before. So yeah, it would just add them up together, and it's a cumulative value, and the right is the argument. So um, yeah, so it just be like this. It's placed before the items of the iterable in the calculation. Yeah, so I can just, is an empty, so maybe I can just have an empty string there instead. Oh, oh, it doesn't add them up together. That's very weird. Because oh, now it's gone for some reason. My list, and filtered this. Yeah, it changes it like for some reason. That's super strange. And huh, that is super strange. So hey, yeah, I think somehow it got changed when I applied this operation there. I don't know why it got changed. I can still add them up like this. I think it's just, I think because doing the type convention it just got crazy. No, it still say that there's no initial value in this list filtered. Yeah, it's still zero for some reason. Um, oh, why is it nothing there? Uh, huh, it is super weird. Now okay, it got something in there, and then oh, I know why, because it's an iterator, so I can't apply it twice. Okay, fine. What I gotta do is I gotta just make this a list. Yeah. So yeah, the reason why it got crazy is because it this filtered is an iterator. So when I call list on it, it created that list, and then it just empty out because it's done. Remember the iterator, when it's done, then it's just that, right? So after I call list on it, it just got this filtered got exhausted. So when I call it the second time, then the whole thing is gone. So now I just make filtered a list, so it should, well, just like stop doing this and then just, okay, so yeah, so now filtered is a list, so it should be fine. It won't get exhausted anymore. So I actually don't need this as well. So um, yeah, so now it works, and then I can just like do what I did before. Um, right, so you just like put them together. So it's that this bunch of numbers, I'll just stick them together. Okay. Um, Yeah, that's very interesting. Like that's why it's always good to know the nature of the Python object that you're using. Otherwise, you encounter that weird thing that I've experienced before. Um, you have to know the hidden state of the Python object, and then you can see that actually it can actually mess up your mind if you are not careful. So yeah, so now it works. So yeah, so you can actually have more complicated operation with reduced, um, or you can just like, for example, x plus y, or I don't like it, I want to put a space between them, or a comma. Then what you can do is like, I just want to add a comma to it. You can do that. Then you got the commas. Yeah, so that's what you can do. And the other thing that we could play around is, yeah, I think this is what you can do with it. And sorry, my chain of thought is kind of like disrupted by that little bug that I found, but that's super interesting that I showed it on screen. Um, I'm so glad that we cover like the iterator thing before, because now you know why, and then you can debug it yourself if you encounter things like that. Um, okay, so uh, actually, there's like more than just reduce there. There's also another thing that yeah. So putting them together. Actually, I'm already doing it. I don't know what else I could do. Like for example, for this, what I can do is that I could what I could do is that I can do the whole thing from the start, right? So this filter thing. So I can just put this because I want to like chain this all together, like just export it as a string, okay? So I can just do this, replace this whole thing. So this time, yeah, my list is a list, so that's fine. I applied the filter on it, and I do the -10, and then I just put them into a comma thing. So, oops, I'm missing some brackets. Yes, so now you got a string with all those numbers. This is how you can put everything together. And just to be careful with the filtered object or the map, the object that got returned, the iterators, this thing is, it return an iterator, and this map thing also, this return an iterator, so just be careful with those, okay? Be gentle with them. Yeah, okay. So, yep. So we have some time left, 15 minutes, not too bad. I thought it's gonna be super so short, but it's not. So I have also put a link at the, oops, sorry, wrong button. Let me go back to there. Sorry about that. So yeah, what I've put down is actually a link to a reference. So this is a very good article by Kuchling, this author. Like this is a very good article. That's why I put it here. Um, he should talk about more like functional programming things in Python, make it slightly bigger so maybe it's easier for you to see. Loads of word here. You don't have to read it now, but it just kind of show you some functions in the modules that could help you to create a to do functional programming. So they also talk about the list comprehension and the dictionary comprehension. So these things I want to actually talk about it next week. So I can give you a preview of this. So basically it's something like this. So you can write it in here. So these are the extra materials, right? We got to cover more next week. So list comprehension. Hello, Lace. Yeah, sorry, I missed your message. Like, why is only popping up now? I think my computer is lagging a little bit, so I only see your message kind of now. That yes, the reason why is because it's an iterator and it got exhausted. So comprehension here. Um, so list comprehension, and let me go there and what I gotta do is to yeah, just write a little bit. Yeah, right. So this is how you can create a list. For example, for that thing, like I want to. So for example, now we have a lambda function. We can also use it in a list comprehension. Okay. So this is another example of when lambda function is useful. Is that, for example, I want to create like 149 again. So instead of doing that thing that we did before, so remember what we did, right? So I just kind of like yeah, capture it a little bit. So we write a lambda function, and then like we just use a map. So this is how you can create this 149, this list. Okay. The other way of doing it is to do a list comprehension, which is for I in 1, 2, 3. Then you do a lambda. What was that? It's n and then n squared. Sorry, like the number that the character that I used to represent the numbers are random. But oops, oops, why is doesn't like it? Wait a second. Like I am having some like mind constipation here. Just one sec. Oh yeah, sorry. Yeah, like I said, mind constipation. I don't know what happened to me. Yeah, so this is like this. It's like sometimes you wake up and you suddenly like can't speak like can't construct a sentence, kind of like that. Oops. Oh, sorry, you don't need the lambda thing here. Yeah, and it's not defined because this is I. Right. Sorry, my mind is just like playing tricks on me right now. I don't know what happened, but yeah, this is how you have a list comprehension. So it's kind of like a lambda function. So you just put in like what you had in the lambda function before here, and then it's just like for I in 1, 2, 3, you just give you this. Yeah, like I said, I didn't plan for this. I plan to talk about that next week, but this is also something like functional programming that put everything in one line instead of writing a for loop. Like you can do things like this, like, and then you have my list, new list. You can do things like that, right? So new list dot append I and oops. Um, Yeah, you can. Oops. Oh yeah, because this is range. Yeah, it's not 1 to 3, so maybe I just put 1 to 3 here. Yeah. So yeah, you can still get the same thing with writing a for loop, but you can actually do a list comprehension like this. So again, another like kind of functional programming trick you could do. You can also do this with a dictionary. I gotta show you next week actually. I'm not going to give away too much, and my mind is starting to be dysfunctional. Um, what another thing that this article cover is that there are sort is another built-in function that is in Python, and yes, this is super long. So what I want to cover is that if you have built-in functions, actually, sorry about the scrolling. So we'll go back to the top. Yeah, sort is actually useful. Um, yeah, sorted. So yeah, this is actually useful because you can actually use it to sort a list. And then the interesting thing is that you can actually customize the key to sort it in a very funky way. um, I can give you an example here, but I'll give you the details. Give you the details next week. Okay, so this is sorting a list. Yeah, sorry about my typing as well. I always feel that I'm so like so stupid when I do live coding because I can't type, I can't speak. I made mistake. My mind's playing tricks on me. I don't know why. But well, first of all, okay, I will just keep it here. I'm not going to execute this because this is going to be useful for me. For example, you can have okay, no, maybe not this. Okay, so you have this, and then ignore the key for now. So you can just sort this list, right? So yeah, it'll sort it according to the ascending order. You can have the reverse here that is not false but is true. You can make this true. Uh, yeah, so then it's in reverse order, or actually, if you use the key, you can make funny stuff. Okay, so for example, what I want to do is that, for example, 24, um, 2, 8. 3. No, let me think of a good example here. Okay, so 3. Okay, so if you saw this, of course, oops, sorry, this one. So you saw this, of course, like this is the biggest, and then, or maybe like, sorry, I need to think of a good example. So this is biggest, and then, going to smallest. But what if I want to treat this as a string? So I can put a key here, key equals 2, and then you can put a lambda function here, lambda x, and then, okay. So what happened is that actually it was treated as a string to sort it. So you can see that because they both start with 2, so they are the highest in the ranking in the string. And then you have, and the least will be 1, 3, 4. So yeah, this is quite strange, I would say. Um, yeah, you can actually change how it got sorted. It could be treated like a string. It's just like, so you can see the difference here. Let me do some like difference. So this is okay. So without the key, and then sort it in a different way. So maybe, yeah, remove the reverse, because this is, yeah, okay. So what am I doing? Can I just stop being stupid for a while? Okay, so right, so this is just, okay, again, the magic trick again. So this is just sorting it as is a number, and if I sort it as a string, so this is what I would get. Okay, and then if I want to sort it as if it's a string, so what I gotta do is I gotta add key equals to lambda, whatever, and then str. Okay, so now these numbers will be, it's still numbers, but it's got treated as if when it got sorted, it will be treated as if it's a string. So yeah, this is like my magic trick. So we're gonna cover like this list comprehension more, and then also sorting a list more next week. And wow, it's an hour. I'm quite surprised that like just covering all this will be an hour. Um, yeah, so I think that's it for this week's episode. Thank you so much for joining me, and so happy to see you, Lace. Sorry I've been like quiet. I'm still recovering from. I hate saying that, but I'm still recovering from my holiday. I don't know what happened to me that like I'm just start picking up work like bit by bit. um yeah, I don't know what happened. But like I said, next week we're gonna talk a little bit more about list comprehension. Also, it could be also to be used in dictionary comprehension. um and also we talk a little bit about how to sort it, and also dictionary, because dictionary is not a there's no order in a dictionary. Okay, so I gotta cover a little bit more. um yeah, it took a weeks to get back. I don't know, like the holiday is just too good. Um, so yeah, like dictionary is not ordered, so I gotta cover like, okay, so what if you want to order a dictionary and all these things like that? I gotta cover a little bit more. I don't think I've covered that last time I talked about list and dictionary, so I think this is more like an advanced on the thing that we know about list and dictionary. There's also some kind of different type of dictionary in the collection module that we're gonna have a look. So yeah, that's what I gotta talk about next week. Again, I feel like I need some more inspiration in streaming. I'm so glad to see you all here and chat with me. It's really helped me to keep going, because like I've already covered like all this basic stuff. So now all this stuff is like a little bit like, oh, what I want to talk about or what I haven't talked about before, and what I'm doing recently at work that I found it interesting. I want to talk about that. So it it's a bit random, and I need some inspiration from you all. So please let me know what you want to know about, and join me in the chat. I'm so happy to see you all here, because like um yeah, I'm happy to like see people in chat rather than I'm just like talking and making videos. That's why I do streaming instead of like just making YouTube videos, because I like people to be joining in and chat with me. um and tomorrow is the legend of data. We're gonna talk about the boosting algorithms, and um, yeah, so that's it from me. And thank you again. I can't thank you all enough to join me and talk to me in the chat. That really inspires me to do more of this. Um, and even if you can't, the time zone doesn't work for you, it's fine. If you have watched my video, send me a message on Twitter. My Twitter inbox is open. Just let me know that you like it, or if you don't like it, you can also let me know what I can do better or what I should talk about instead. um, that will help me to feel like that there's why I'm doing this. This is actually helping people, actually what I can do to help people. um, yeah, and so that's it from me, and enjoy the rest of your weekend, and I'll see you tomorrow for the Legend of Data. And also remember, we have meat pie every Wednesday. We still haven't decided to change the time yet. I need to, yeah, Lace, like I need to talk to you like later today. So yeah, I will see you very, very soon. Bye.